Hello friends, so in today's question, three blocks A, B and C of mass is 1 kg, 2 kg and 3 kg respectively are arranged as shown in the figure. The coefficient of friction between the surfaces are also shown in the figure. A force of magnitude 20 Newton acts on the block B in the horizontal direction. Then the acceleration of block A is. So this is the figure. Blocks are A, B, C, respectively 1, 2 and 3 kg. A force is being applied of 20 Newton to block B, and the coefficient of friction between A and B is 0.5, B and C is 0.4, and between C and the ground or surface is 0.3. So let us say this is mu1, mu2 and mu3, and let us denote all the respective forces that will be acting on A, B and C. Okay. So this is block A, block B and block C. A force of 20 Newton is being applied on block B. So force F, which equal 20 Newton. Now this B will try to force A to move along with it. So let us suppose with the help of the friction, so let us call this as FR1. Therefore equal and opposite will be acting on block B also. This will be also FR1. And block B also will try to move block C along with it. Let us suppose this is friction FR2, and equal and opposite will be acting on B also, so FR2, and between the surface and block C, let us suppose that friction is FR3. So let us find out what will be the maximum value of FR1, FR2 and FR3. Okay, so we can say the FR1 max, which can also call a limiting value of the friction, will be equal to mu1, and let us suppose the normal is given as NA, and for A, let me draw it here. So this is block A. It is going to have MAG in the downward direction and the normal NA in the upward direction. So NA will be equal to MAG, so we can write this as mu1 MAG, and we get FR1 max is equal to mu1 is our 0.5, this is MA, mass of A is 1 kg, and this is 10, G is taken 10, so we get this as 5 Newton. Okay, so this was for block A. Now let's find out for block B. So this is our block A, which is resting upon block B, and so we get this as this will be MA plus MB into G, and let that be normal will be NA plus NB. So we get FR2 will be equal to mu2 NA plus B. Mu2 is 0.4 and NA plus B is MA plus MB into G, and it is 1 plus 2 into 10. So we get our FR2 max, rather, let me call it. This will be equal to coming as 12 Newton. And let us find out it for block C also. So we can say for block C, so we have block A, block B, and this is our block C. So in the downward direction there will be MA plus MB plus MC into G, and in the upward let us call the normal as N A plus B plus C. So we can write our FR3 max is equal to mu3 multiplied by N A plus B plus C. So we can say from here FR3 max mu3 is given as 0.3, and normal will be equal to MA plus ME plus MC plus into G. So this is 1 plus 2 plus 3 into 10. So we get this as FR3 max is equal to 18 Newton. Now let us assume that all the blocks move together. Okay, so assuming all blocks A, B and C move together with the acceleration A. So they are moving together. This is our A plus B plus C, a force F which is equal to 20 Newton with the acceleration A, and we have a friction force FR3 max because it is already moving. So FR3 max we already know is equal to 18 Newton. So we can say F minus FR3 max is equal to MA plus MB plus MC into A. F is about 20 Newton, so this will be 20 minus 18 is equal to, this will be 1 plus 2 plus 3 A. So we get A as, this will be 2 divided by 6. From here I can say A is equal to 1 by 3 meter per second square. So this is the maximum acceleration with which A will be moving, B as well as C will be individually moving. Okay, so we can say this is the maximum acceleration with which block A, B and C will move. So we are only interested in block A, so it means we can write it here, block A maximum will be given as 1/3 meter per second square. But we have to find out whether this maximum acceleration is possible or not. Okay. So in order to do that, what we do, we consider the block A. Let me write it here. Let us find out whether this value of acceleration of block A will be enough to have or to generate the required value of friction. So based on this acceleration, we are going to find out what will be the value of the FR1, that's friction, and then we compare this FR1 with FR1 max, and we can draw the conclusion from there whether this acceleration is feasible for block A, individual for block A is or not. Okay. So let me write here, this is block A. It is moving in this direction with acceleration 1/3, and we have a friction FR1. So I can say my FR1 will be equal to ma into A. Mass is given as 1 and acceleration 1/3. So we get FR1 is equal to 1/3. Now let us compare this value of FR1 rather, with FR1 max. Okay. So we already know, let me write here, FR1 is equal to 1/3 and FR1 max is equal to 5 Newton. From here we can say the value of the friction FR1 is less than FR1 max. It means the block A will not move individually. Okay. So from here we can say that FR1 is less than FR1 max. So this means no slipping between block A and block B. Or we can say block A will move together with block B. Okay. So under this condition, if they are moving together, so it can be said that this is our A plus B and the force of 20, and we have a friction of FR2, and this will be FR2 max. It is moving. Okay. So we can write the equation that, let me write here, therefore for block A and block B move together with acceleration capital A. Let me write it. Capital A will be block A, so let me write A plus B. So they're moving in this direction with the acceleration of A plus B. Okay. So therefore we can write the equation that applied force F minus FR2 max is equal to MA plus MB into acceleration of A plus B, and we know already value of F, that is 20, FR2 max is 12, and this will be equal to our 1 plus 2 into A plus B. So from here we can write that acceleration of combined acceleration of A plus B will be equal to 8 by 3. And let us check out for whether C will be also moving along with A plus B, or C will be moving, slipping will take place ideally. Okay. So we can say check for slipping between blocks A plus B and block C. So basically it means this is our A plus B and this is block C. Okay. So we have a force of 20 Newton. This is our FR2, and this is our FR3. So we can write the equation as (20 minus FR2 is equal to 1 plus 2, and acceleration is 8 by 3. So from here we can find out that this will be our 3 into 8 by 3. 3 and 3 goes. So we can write that FR2 is equal to 20 minus 8, which is equal to 12. So FR2 is equal to FR2 max. Therefore, slipping between combined of A plus B and C is going to take place. This says that slipping between blocks A plus B and block C will happen. Therefore, we can say that the acceleration of A plus B will be equal to 8 by 3. Okay, or we can say that acceleration of block A will be equal to, let us call this A, will equal to A plus B, and which is equal to 8 by 3 meter per second square. This completes the question. Thank you.